So covalent bonding is the electrostatic attraction between a shared pair of electrons and positively charged nuclei. Those electrons are called bonding electron pairs, the ones that aren't bonded, such as in O2, these ones here. On the outside there, the non-bonding pairs. Okay, so just a little bit more of a detailed diagram, a different type of diagram here. Increased electronegativity. The ionic happens at 1.8 or a number close to that, maybe 1.9 depending on your textbook. So increasing polarity, this is an increasing polar covalent bond. This is a non-polar covalent bond over here. And so the electrons here are smack bang in the middle. These ones are a little bit more to the other side, and these ones are attached to here. So this one's considered negative and this one's positive, cations and anions. So with the covalent bonds, there's two important distinctions to make. First of all, these are small molecules, so simple covalent molecules. They only have weak intermolecular forces, which will come up in a further video. And so these things don't stick as well together in mass. And so these things have actually low melting and boiling points because they're only stuck together by intermolecular forces. Whereas the covalent lattices are all joined together by covalent bonds. So this is silicon dioxide here. Diamond's even stronger. It's just all carbons joined together. And so they're intermolecular. They don't have intermolecular forces. Their intramolecular forces are all covalent bonds. They're all stuck together. So these will have the opposite. They'll have high melting and boiling points. Now, the shorter the bond, the stronger the bond. And so when you see here, you see single bonds, double bonds, and triple bonds. The single bonds are weaker than the triple bond, but per bond, they're actually not stronger. So if I just go to a table, if you see this example here, so you can see that triple bonds take 835 kilojoules of energy to break. You'll do bond enthalpies in further on in the units. But if you divide this by 2, so single bonds might only be 364, but per bond, this is actually only 301, and this one's even weaker. So they are actually easier to break per bond rather than overall. So making a triple to a double or a double to a single. And plus there's a huge amount of electric attraction here for the positive cations, or what we call electrophiles. So here's a good summary of the three now that you've watched the three videos. So ionic is the electrostatic attraction between cations and anions. And so if you have a small ion with a large charge, that's going to have a stronger ionic bond. Covalent substances are electrostatic attraction between two nuclei, and so the shorter the bond, the stronger the bond. With metallic substances that are just cations in a sea of electrons, the smaller the metal ion, the larger the charge, and the more free electrons floating around also increase the strength of the metallic bond. Okay, so these are the three main types of bonds, and they are very strong bonds. Intermolecular forces will come in another video, which I might remember to put up in the corner.